Okay, so this one is this is 6.35e, and we're asked to, I guess, simplify this, right? To add, subtract. So what we need to take account here is a look at the denominators, right? We need to make sure we have a common denominator. So what we're looking for is the lowest common multiple. Now, not the lowest common factor. There's a difference. Lowest common factor would be, the smallest piece that would be factors of all of these. We don't want the smallest. We actually want the biggest. We actually want, the kind of the bigger one. So multiples of 5 would be 5, 10, 15, 20, and so on. That's multiples. Multiples of 10 would be 10, 20, 30, and so on. Multiples of 15 would be 15, 30, 45, and so on. So what you see is the lowest common multiple of all these three would be 30. Not factor. The lowest common factor, or the greatest common factor, would be 5. So we're not going to go there. We need to go to multiples. So we know that we have to get to 30 here, okay? Also, with the variables, we have to get to t cubed, okay? That's the lowest common multiple. You have t squared, t cubed, and so on. Well, the lowest common multiple here that's common to all would be t cubed. So we have to write each of these over 30 t cubed. You see that? Now, do you have to write them all separately like this? No, I'm showing every step, so you don't have to quite do it exactly like this. But hopefully you get the idea of what we're doing. So what we have to do to 5t squared to get 30t, well, we have to multiply by 6t. So 6t goes up top there as well. I have to multiply top and bottom by 6t. This one, we need to multiply by 3t squared. 3t squared, top and bottom, to get to 30t cubed. And this one here, just have to multiply by 2, looks like. So 2, okay? So the top is going to be what? 12st. 12st. Just show it just like that. And this one's going to be 3t squared. And this one's just going to be 12, okay, up top. So now that we have this, we can show this as a single term. So I'm going to put the 3t squared first. I'm going to add the 12st. I'm going to subtract the 12 here at the end, all over 30t cubed. Now, if we have to totally simplify this totally, then this new term, we can kind of see that we do have a common factor, looks like, okay, of 3 on the top. I can pull a 3 out, and I can pull a 3 on the bottom, so we're going to be able to simplify that. So am I on the right track here? Is this the question asking to simplify fully correct? I haven't actually looked at the text here yet. So if we pull a 3 out, then we're left with t squared plus 4st minus 4. Pull a 3 out of there, right? Divide 3, divide 3, divide 3. And then if we divide 3 out of the bottom as well, we get 3 times 10 t cubed. So I don't have any t's in this term here, so I can't pull out a t as well. And of course, no s's in all the terms. So now these 3's can go away, and it appears that we have this as our final answer, because it doesn't look like we can factor these any further. So does that look like what you guys got, those of you that did do 5a? Or 5e, I guess? Can I get an agreement there? So the final thing that we would want to do here is the question asks to state the non-permissible values. So up here in the question, obviously t cannot equal 0, because that's the only thing that would make trouble in the denominators. That would make the denominators 0. So t also cannot equal 0. That's part of your answer. Okay? So there's 5e. Let's take a look at 6a now from 6.4. All right, so this is 6.4 now, 6.4, 6a. So we're asked to solve the quadratic equation, round answers to the nearest 100th. So we might have decimal answers, not just neat whole number answers or integers. So we're taking a look at a here. So for a, what we want to do is we want to eliminate the denominators. So again, you don't have to get a common denominator. I see that there's addition, and so you might say, oh, I need a common denominator over here. Well, yes and no. I mean, the thing is, we've got all sorts of denominators here. So what we want to do is eliminate them all together. Okay, and how we do that, if you recall, is we multiply the whole equation by the lowest common multiple of all the denominators. So in this case, and maybe I'll just I'll do this. So in this case, I want to multiply each term, all of these terms, by b plus 5 times b minus 2. Or multiply all of them by b plus 5, then multiply all of them by b minus 2. You can do it separately if you want. You don't have to. So that goes to all of these, to this one, and to this one. You have to remember that. So what does this look like? Okay, so when I do b plus 5 times b minus 2 times this first one over here, the b minus 5s go away. You see that? So I'm left with 26 times b minus 2. That's what I'm left with. Okay. When I multiply this times 1, well, I'm just left with, and that's the equal sign, let's throw that in there, I'm just left with b plus 5 times b minus 2, right? All right. And when I finally do this one, multiply these two times the third term I see in this equation, well, the b minus 2s are going to go away. They're going to divide out, and it's going to be 3 times b plus 5, right? So plus 3 times b plus 5. So that's the first and most important step in solving equations. Get rid of the denominators. Multiply by the lowest common multiple of the denominators. And in order to see that, you will need to factor the denominators first. Like in b here, okay, you need to factor this. That's actually c plus 2 times c minus 2 for this one. So factor them first so you can see exactly what factors you have. All right, so back to a here. I'll continue this down here. So it's going to be 26b, as you got to distribute this, minus 52 equals b squared. Now, I'm going to do some things in my head here. Minus 2b plus 5. What's minus 2 plus 5? Plus 3. Plus 3b. And then 5 times negative 2 is minus 10. Plus, and of course over here, we've got 3b plus 15. You good with that? So we want to gather like terms and see if we can solve for b. Well, I see that b, I have a squared term here, and I have a whole bunch of just regular old b's. So it looks like we might have a quadratic of some sort, which is no problem. A lot of these turn out to be quadratics, so we can solve those. So let's see. Plus 3b, that's going to be 6b over here, and then we'll subtract 26b. So we're going to have, I'm going to leave that b squared alone. That's going to be 6b, and then minus 26b. So that looks like it's minus 20b to you. Okay, so 6 minus 26. And then I've got 15 minus 10. Okay, so that's going to be 5. And then I'm going to add 52. Right? So is that plus 57? 26, 52, add 52, 15 minus 10, 57. Does that look good to you? Okay. Yes? Agreed? Okay. So, yeah, this might be tough to factor, right? What are the factors of 57 that add to negative 20? Do we have any? Yeesh. Probably not. 57, is that prime even? I said 27, 30, no, not quite prime. Well, actually, so what are the factors of 57? Let's see, that's 30 plus 27, so that's going to be, if we divide it by 3, that's going to be 10, and that's going to be 19. So is that 19 times 3? Ooh, doesn't quite get us 20, right? So you can try and factor this and see if those factors add up to 20. I'm not thinking they do. Is anybody agreeing with me there? I'm not seeing that those. Okay. So we had a little bit of a clue here in the question, didn't we? Answers to the nearest hundredth. So guess what? We're probably going to have to either graph and find the intercepts. You know how to do that. Or we should probably, well, we could complete the square, I guess, right? But that's still going to be pretty tough to find intercepts there. That'll help us get the vertex, but we don't want that. So quadratic formula, that's where you're going to want to go. If it's not easy to factor, just go to quadratic formula. It'll never fail you. So b is going to be our b. So x equals, or b equals negative b. So that's going to be actually a positive 20, plus or minus the square root of b squared. So that's negative 20 squared. Minus 4 times a is 1 times c is 57. All over 2a, or 2 times 1. Okay. Good thing to check. Let's make sure we do this b squared minus 4ac first, and to see if we have any solutions at all. Because it could possibly be that we have no solutions for this. There could be no answers. And how would we know that? We would know that because our determinant would be negative, right? If that's negative, that means that there's a problem. That means that we have to take a square root of a negative number. There's an issue there. That's your clue that there are no solutions. Okay? So let's check that first. I think that would be wise. So this turns out to be, turn my calculator on there. Oh, that's an interesting page there. So this turns out to be negative 20 squared. Well, that's the same as positive 20 squared. So that's going to be 400 minus, okay, 4 times, well, I don't need to do the times 1. 4 times 57. Okay, good. It's positive. So I'm going to have possibly 2 answers here, right? That's what that means. Remember the nature of the roots, right? If b squared minus 4ac is positive, we have 2 possible roots, 2 real roots that we're going to have to consider. So b equals 20 plus or minus the square root of, that was, well, I'll write it. Was it 172? Was that what it was? Okay. Over 2. Whoops. Over 2. Over 2. So what's the square root of 172? Where were we? Square root of the answer. 13.11. Nice. So we've got 20 plus or minus 13.11 over 2. That should yield us 2 possible answers. We'll evaluate those, and we'll have to check those, right, to make sure that each one of them is possible. So what's this going to be? Well, let's just calculate that real quick. Okay, so the 2 solutions I get with the calculator, 16.55 and 3.45. So are any of those restricted values? Oh, I should probably note my restrictions. B cannot be equal to, oh, that's easy, negative 5 and positive 2. Negative 5 and positive 2. It just so happens that neither of these answers are negative 5 or positive 2. So if these are the only restrictions, it looks like these answers both might work. So what we'd want to do is plug in our possible values in for B, do some quick evaluation, and see if the left side equals the right side. That would be your check. Okay? And then you have to do that before you solidify your answer. So yeah, so if we look at the solution manual here, okay, they've multiplied everything, of course, by the factors that we identified there, the denominators. And of course, they did quadratic formula as well, and it looks like 16.56 or so and 3.44 are the answers, and that would check out then. Okay, so those would check out. You can confidently say, now we've rounded a little bit differently, so that's fine, but I don't know why I did that. I'll make the answers green today. There we go. Because green is the color. Football is the game. There we go. Those are our 2 answers. You circle those, identify those, show a little bit of a check, whatever you do to check. Okay, so that's what your evaluation in Chapter 6 is going to look like. You're going to have some of these questions on there, so hope that helps.